I'm going to show how to make a hexagon grid using Affinity Photo's procedural texture filter. I've been trying to make a hexagon grid pretty much since I first learned about the procedural texture filter, and I looked at a lot of tutorials on YouTube on how to do this in other languages like Blender or Unity or Unreal Engine, and I finally found one that I thought worked pretty well. Has a complete set of features and works to make the hexagon grid. This one was by Left Brain sqrt. So this example is based on that one. I'll put a link to that video in the description for this video. The overall procedure I'm going to use is to first create a hexagon shape using something like a signed distance field, and then I'll create the grid, and then I'll combine the two and put my hexagon shape into the hexagon grid. To get started, I'll start with a 1024 by 1024 pixel document and create that one. I'll just color it black. And I'll add a new live procedural texture filter. I'm going to start with a real number custom input for A scaling factor, and I'm going to start with a variable V, a coordinate variable, which is vec2 of rx comma ry, so relative x, relative y, that way I'll be able to drag it around with my mouse, times a divided by w. So a is my scaling factor down here, w is the width of the document. And if I just look at what that looks like, I'll assign that to all three channels. So the x coordinate, this is the origin down here. If I double click on this, it'll move the origin to that location. And the x-coordinate increases from 0 at this point up to 1 at about this point. Then it just stays, it doesn't get any brighter than 1 because the red color can only go up to 1. The coordinate is still increasing to higher and higher values out here. The y starts with 0 up here and increases as it goes down. Now I'm going to take the first thing I'm going to do is to take the absolute value of V like that. And I'll zoom in on that a little bit. And I'm going to turn off the green channel for a second. So the red channel looks like this. It's vertical. Green channel is horizontal like this. And so if I were to look at this, it would form sort of a pyramid shape if I imagine that as a three-dimensional object there. The next thing I'm going to do is I'm going to apply a dot product to this. So dot products are one of the common mathematical operations you can do on vectors, and it's defined as the dot product between A and B is defined as the magnitude of A times magnitude of B times the cosine of the angle between the two vectors. And so I'm just going to, let's do that and see what happens. So absolute value of V is a vector. You can see it has two different colors. So I'll just get started. I'm going to take the dot product of absolute value of V and vec2 vector 1 comma 1. So this is just a constant vector, and then absolute value of V looks like this. It's changing like that. And when I do that, I get this diamond shape. In fact, if I put in the blue color as well, it's no longer a vector. It's now a scalar value, and it has this diamond shape like that. Now it almost looks like a hexagon. If I could chop off either one of these corners, I'd have sort of a distorted hexagon. So let's start with that. It turns out, though, that if I put in the square root of 3 for one of these, it gives me the dimension I need. So now this, if I were to be able to measure this, it would form a 120-degree angle like that right there. And then I could, if I cut off these corners somehow, I would have a hexagon. So I'm going to take this vector and I'm going to make it into a variable. Take it out of there. I'll make a new variable. I call it SV for scaling vector. And I'll put it in over here. And I'm actually going to use the square root of 3 as the first value on that one, and the comma 1 as the second value. And then I'm going to put in SV over here, and let's see if that worked. And get rid of that parentheses. There. So when I switched the square root of 3 and the 1 around, it changed the orientation of my diamond, like that. The other thing I need to do to this is to take the normalize it. That'll sort of make the overall length of the vector equal to 1, but it'll still keep these same sort of ratios between the components of the vector. What it does for my diamond is just make it larger in this case, so I'm going to zoom out a little more, like that. I'm going to add a new equation. I'm going to copy this one and paste it down here. I'm going to turn this off, and I'm going to change this now and make it into, I want to look at another function. I'm going to look at v.y. Look and see what that looks like. I'm going to look at absolute value of v.y, like that. And I'm going to just put that on just the red channel for now. And I'm going to put this one on the green channel for now. So, okay, so if I look at this diamond here, if I could chop off these edges, the top and the bottom parts, I would have a hexagon. And it turns out that if I just take the absolute value of v.y, it'll create a function that I can use to chop that off if I take the maximum, max of v.y and this dot product. I'm going to bring that in, comma, dot product, like that. And I'm going to turn this one off. And there I have the hexagon shape. I can rotate this hexagon shape, and I'm going to need to do that later. One way to do that is just to swap. I have to change this to an X. Oh, and I'm going to change these, turn all of these on, like that. And I can use a, there's a special function called swap that swaps the two components of a vector. So if I do a swap 1, 2 on this, like that, it'll switch the orientation of my hexagon. It isn't an actual hexagon yet, but I'm going to use a step function to make it into a hexagon. So the step function looks at an edge, a grayscale value, or a value between 0 and 1, essentially, and uses that as the edge between black and white. But there's another set of step functions there, the smooth step functions, and I'm going to use the linear smooth step function, and that one takes two edges, and it runs through the grayscale from black to white, where these edges occur in the grayscale of the image. Okay, so let's take a look at how that works. Have that. I need to add my two inputs for the two edges, edge 1 and edge 2. And if I bring this one all the way down to 0, I have the original image. But as I bring this up, the hexagon in the middle gets blacker. And as I bring this down, the white area gets larger until they sort of meet in the middle. And then I have a black hexagon on a white background. Now I probably actually want to have a white hexagon on a black background, so I'm going to take 1 minus all of this. That should switch it around. So now I have my white hexagon on a black background. So that's everything I need for my hexagon. I'm just going to copy this and paste it down here for now. The next step is to build up the hexagon grid. In order to build up the hexagon grid, I'm going to first do a single row of hexagons, and then I'm going to skip a row and do another row. So I'm going to set it up so it's sort of alternating every other row. If I look at the trigonometry involved in this, if I measure the distance from center to center of a hexagon and call that 1, if I go up to this one now, it would be over 1 and up the distance of the square root of 3. This turns out to be a 30-degree angle. The length of this side is 2, and then if you use your trigonometry or the Pythagorean theorem, you can figure out that this has to be the square root of 3. So the square root of 3 distance is going to be able to move this grid. I can reshape my grid based on these dimensions. And I've already got the vectors set up for that, and so I can use that vector to scale my grid size. So I'm going to leave this normalized vector set up like that, and I'm going to change this coordinate system to v0, and I'm going to delete all of this. I'll put that back in later. And so if I look at v0, it looks like that. And to get started, I'm going to take the fraction of v0. So fraction gives you the fractional part of a real number and throws away the whole number part of that number. In this case, it's generating negative values, so those are just all black, but I'm just going to move this until it's out of the way of that. Okay, so there's my grid, and it's each of these. I've got copies now of my grid, where each of these go from 0 to 1. 0 to 1 in the x dimension, that's applied to the red channel. 0 to 1 in the green dimension is applied to the green channel. The first thing I want to do is to move the origin to the center of the hexagon, so I can do that by just subtracting off a 0.5 from this, and it moves the origin of each of these little squares right here. The next thing I want to do is to scale this so it matches that 1 square root of 3 ratio, and I can do that by just multiplying by my scaling vector SV. So if I multiply by SV, so now it changes the ratio of the grid. Still, the colors are centered on an origin here in the middle of this, and it shows a pattern like that. Next thing I'm going to do is I want to look at the length of this. I'm going to use length here in a minute to figure this out, but I just want to show something that happened. So when I look at the length of this, I notice these look sort of oval. It'll look more, it'll be more noticeable if I add an adjustment to this. So I'm going to add a gradient map, and I'll choose one that has, where you can see that pretty clearly. Like on this one, you can clearly see that oval shape. Now, in order for this to work with my hexagon, I don't want it to be distorted in this oval shape like that. I want these to be circles. So when I did that multiplication, I introduced that type of distortion. To get rid of this oval shape, I'm going to take my coordinate system and divide by SV, like that, and now I have circles. So it seems like I just multiplied by SV and divided by SV, but it's going to work out. I did take the fraction operation in between there, and now I've got circles again. So now this is going to work out for my hexagons when I get to them. It's a little harder to see that they're circular now, but they are circular. So I'm going to use that. I'm going to take off the length, and I'm going to actually use this as my as a variable. I'll call it v1 equals let's see, I have to add the variable in there. Variable v1 equals fraction of that. Okay, so there's my v1, and now I'm going to make a v2, and I want the v2 to be shifted over. So if I look at my geometry again, the V2 is going to be this set of hexagons, so the alternate rows. And these are moved over by 1/2 in this dimension and up by the square root of 3 over 2, or half of a square root of 3 in that dimension. And it turns out the way I have this set up, see, I have to change this to a V2. All I have to do here to do that shift is to add a 0.5 inside of this fraction. So with V2, it's been shifted by half a unit in both the X and the Y. Now for the tricky part. And I did not figure this out myself, but it's very clever and it works. If we use a step function, and remember the step function determines which part's white and which part's black based on a boundary. And for the boundary, instead of just using a constant like we did before for the edge, if we take the length of V1 and the length of V2 and apply it to the length of V2, I get this pattern. Okay, so these are each individual hexagons. Okay, not only that, but if I multiply this by V1, I get individual coordinate systems confined to a hexagon grid. Okay, so I've set up little hexagon-shaped coordinate systems here. I can copy this and paste in another copy of it, and this time I'm going to swap out V2 and V1 and multiply by V2. And I'm just going to add these two step functions together. And there we go. I have a full hexagon coordinate system ready to go. And now I can apply my other function in there and I'll have my array of hexagons. You could put some other sign distance function in here to get different shapes in a hexagon array, but I'm going to do hexagons today. I'm going to assign this to a variable, V3, like that, and I'll just check that to make sure that worked. Okay, so there's V3, and now I can put my hexagons in the middle of this by copying my function from down here, putting that over here, and then instead of having just v.x, I'm going to have v3.x, and a v3 here, and I think that's it. So let's see if that works. Yes, so it created my hexagon array, and this controls the width of the lines between them, and then this one sort of smooths the edges. So by manipulating these, I can control the overall shape of the hexagons and how smooth they are. If I turn on my gradient, I can create a series of gradient hexagons. Now, if I wanted to change the orientation of these, currently they are aligned vertically, but if I wanted to have the flats aligned horizontally, I can do that. The easiest way to do that is to go to this scaling vector and change this, take out the 1, put a 1 comma in over here, and then over here instead of an X, I'll put a Y. And there it's moved them so that they are oriented in the opposite direction. And I could put this one down here if I wanted to. So I have, and then change this one back, and I could have the other version of it. Okay, so that's my hexagon grid with hexagons. Let me know if you have any comments or questions, and thanks for watching.